Hi class, for these sections we're going to talk about hyperbolic functions. So as you know that the trig functions are closely related to the circle. So these functions are related to the hyperbola. Um, we still have to apply everything when it's come to derivative. We have to apply every rule for the hyperbolic functions. So these are the definitions. I understand that it's really hard to memorize these definitions, but some functions they are very close to the trig functions. So, for example, you see the hyperbolic tangent is like hyperbolic sine over hyperbolic cosine, so they are the same. Okay, let's take a look at example one. We want to prove that identity. I'm just gonna use the definition to do it. So you see that. Let me just copy it. Equals 2. So how about I just write down the definition? E to the x power plus e to the negative x power over 2, and you want to square it, minus, and we have e to the x power minus e to the negative x power over 2. I square it. Okay. We just pretty much FOIL. So what I have is e to the 2x power plus 2 plus e to the negative 2x over 2 squared is 4 minus e to the 2x minus 2 plus e to the negative 2x. So you can see that what we have, we cancel, 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 cancel. So I ended up with 4 over 4, which is 1. Okay, so you see the top is just 2 minus negative 2, which is 4. Okay, so for the second part, we want to prove that 1 minus the hyperbolic tangent square is going to be the hyperbolic secant square. Okay, so I'm just going to rewrite the identity we proved earlier. This is what we have. So keep this in mind. Okay, so what I have is, so let's say that I want to divide both sides by hyperbolic cosine square. So this is what I'm going to do. I'm not changing anything because I divide everything by the same values. Okay, so what we have is 1 minus hyperbolic tangent square equals to 1 over hyperbolic cosine square is just going to be secant, hyperbolic secant square. And there we have it. Okay, all right, so these are the derivative of these functions, and we have the definition of the inverse. So they are similar. I know it's a lot to memorize. I don't expect you to memorize everything, but like I said, they are similar to the trig function. As you can see, the derivative of the inverse, just like the derivative of the trig function. Okay, now let's take a look at what I have right here, this example. Notice that the reason I want to go over this example is because we still have to apply the chain rule here. So what do we have? So what I have right here, I'm just going to rewrite x to the 1/2. Okay. So the derivative, I'm going to take care of the outer function first, which is the hyperbolic cosine, which is just sine, hyperbolic sine, square root of x. And then we do the chain rule. So is 1/2 x to the -1/2. So I should rewrite. Notice that for hyperbolic functions, we don't have the negative for the derivative of cosine. And that's my final answer. Okay, now let's try a different problem. How about we try to prove some identity. So let's say if I want to prove the derivative of the inverse of hyperbolic sine of x is going to be 1 over square root of 1 plus x squared. Okay, so how do we prove this? Now, what if we let y to be the inverse hyperbolic sine? That means the function is going to be, the function of y is going to be x. This is just the identity of inverse. All right, now I'm going to differentiate the equation implicitly with respect to x. So I want to do this. Okay. So what do we have here? We have hyperbolic cosine. Don't forget the chain rule. So I still have to include dy over dx. And then the derivative of x is just 1. Okay. Keep in mind that we have earlier the square. If you subtract, you're going to get 1. This is the first example that we did. And we know that the hyperbolic cosine of y is going to be positive. All right, so we have hyperbolic cosine of y is going to be, and then if I take this, if I subtract it over, take the square root, it's going to be 1 plus hyperbolic sine square. Okay, so what is dy over dx? Dy over dx is going to be, okay, so you see from here, I just divide. So I divide cosine, hyperbolic cosine. Okay, and then I'm going to substitute it in 1 plus. Okay, so from here to here. And then I'm going to go back and replace it by x. So we have the result. Square. There we have it.